Hello students. So in this lecture we will discuss about classification of molecules. And these classifications will be based upon the three moments of inertia. We call it IA, IB, and IC. These are the moments of inertia. Now, I will tell what are these IB, IB, and IC. Now, first, let us start with the first group, which is called the linear molecules. Now, in linear molecules, all the atoms are arranged in a straight line. All atoms are arranged in a straight line. For example, HCl and also OCS, carboxysulfide, now as told you here that there are three directions of rotation if you take linear molecules. For you are considering a molecule E and B, rather than put it in this way. This is a linear molecule. So it can rotate about the bond axis. So this is the bond axis. It can rotate like this. So that rotation, moment of inertia corresponding to that rotation, I put it as IA. It can rotate like this, end to end. This can go to this can go to this. I would put it as IB, and it can rotate end to end perpendicular to the surface. That means if this is parallel to the surface, that is the motion is along the surface, it is in touch with the surface, or it can rotate perpendicular to the surface and it comes to this point and follow this path, or it can follow the perpendicular path. So for that perpendicular path, it's given as IC. Now for linear molecules, the end over end rotations, that means IB and IC, they are equal, whereas the bond axis rotation is very small and is close to zero. This is how the linear molecules are characterized. So the second group of molecule is called symmetrical tops. And example of a symmetrical top is CH3F, where they have three H molecules bonded to a carbon molecule, and then F. So here, similar to the linear molecule, here also the end over end rotations for both these in plane and out plane they are equal. The only thing is that since this part is very heavy and very big, so the IA is actually not equal to 0. It is quite significant amount. So there are two classifications of the symmetrical top. One is called the first case is where IA or IB is equal to IC, then to end rotations owing to inertia are more than the bond axis rotation. And in that case, it's called a prolate symmetrical top. Examples being at this H3F. The other classification is quite opposite. That means when IB and IC are less than IA, less than IA. And example is say CL3. Then it forms an oblate spheroid or oblate symmetrical top. So this is the symmetrical top. The third classification of molecule is spherical tops. In spherical tops, all motor inertias are equal. IA is equal to IB is equal to IC. So it is a symmetric molecule. For example, methane CH4. Now, it is observed that for any rotational spectrum, the rotation should produce some change in momentum or change in dipole moment. But for spherical tops, since it is a totally symmetrical molecule, rotation will not cause any dipole moment, so it cannot produce any rotational spectra also. So the last group of molecules based on motor inertia are the asymmetric tops. And here there is no equivalence. That means none of the motor inertias are equal to each other. So IB is also not equal to IC, also not equal to IA. And the majority of substances actually belong to these asymmetrical tops. And if we take samples, then H2O, then CH2, CH, Cl, they are good examples of symmetrical tops. So the motor inertias are not equal, and the oxygen molecule, we can see it looks something like this, OH. So rotations, end-to-end rotations or bond axis rotations will not cause any similarity between the momentum inertia if it is done in the opposite way or the reversed way. Similarly, you have CH3, so 2 Cs bonded together, followed by hydrogens and one chlorine. So this is the size of C6Cl. So you can see that there are four classifications: spherical tops, symmetrical tops, linear, and asymmetric tops. This is how the classification molecule is done based on governmental inertia.